Recording's in progress, so let's go. We're going to talk about these topics: virtualization and cloud computing. Virtualization, we're going to break it down into like 3 different things: virtual machines, virtual networks, and the cloud and virtual private networks. So let's have a look at that. Virtualization. It's where you're going to make virtual means it looks like it's real, but it's not. So you're going to have a virtual machine. It looks like you've got a real machine, but it's actually just something that's sitting in software on another machine with some other virtual machines. Or you could have a virtual private network. It looks like you've got a connection of a private network, but you're actually just piggybacking off somebody else's network using a tunneling technique with a bunch of cryptography and a bunch of security. Cloud computing, we'll talk about that as well. We will look about some of the encryption protocols that are being used. That's at the end of the lesson, if we get that far. I'm going to try and sort of work my way through it. You know, I think I can talk pretty fast, so I'm going to try and sort of let's get through this and do it. So as it says, a virtualization is where you have something, it's not physical. You know, I mean, if we're going to say what it isn't is it's not physical. It's not actual. It's something that appears to be, but is not physical. So we're talking about the host in our virtualization because we're going to use a host computer and put, for example, virtual machines onto it. And so the host will support a single physical computer can support multiple virtual machines. So we use the word host in that context. So we use the word guest as being the virtual machines which are sort of living off or living in, or in the software under the operating system that's running on that host machine. So they get the guest. Now hypervisor, we refer to that as a sort of a method of actually implementing this. To make a virtual machine, we use hypervisor. And hypervisor is not a proprietary word. It doesn't, we're not referring to VM or Cisco or anything like that. They all have their different versions of hypervisor. So hypervisor is a way of doing this. So what hypervisor does, or what we mean by that, is it's going to create and manage a virtual machine. And as I said, there's many different ways of doing this. And many of the network software providers, they will give you their version of hypervisor, VMware, Cisco, etc. As it says, it manages the resource allocation between the host and the guests on there. Now, we've got a couple of different ways of doing this hosting and hypervisor. So we just use hypervisor, say hypervisor 1 or hypervisor 2, which is sort of relating to the different ways of doing this. So what this diagram is trying to show you is, as I said, you've got the physical machine, which is represented by the gray box. The diagram is kind of a cartoon diagram, I guess you could say. There are not actually little machines living inside of it, but you can imagine that as far as the user who's connecting to this, it's as if, as if they had little machines living inside it. And that's all done by sort of software, the hypervisor. And so we noticed there that we've got a single network interface card connection to the network, and the network interface card is actually going to interact with these virtual machines. They will use that network interface card the same way as a physical computer, which is their host, does. And here we have the 2 different types of hypervisor, type 1 and type 2 types of hypervisor, shown in a sort of a model diagram. So what the difference is that the one on the left, the type 1, okay, we call that a bare metal hypervisor. What the bare metal hypervisor is doing is you actually just take your host machine and you put the you have a special little bit of operating system that comes with the hypervisor, which just provides you with a layer that you can connect then to have multiple virtual machines working off of that. So they have their different operating systems. There's nothing that was there on the original machine that is being used in terms of software. The original machine, we call it bare metal because the hypervisor actually has its own little operating system. It's not very feature rich. It's just enough so that then we have these other the other multiple operating systems there are one operating system for each of the guests. Now, That's as opposed to the type 2 hypervisor. You're going to use the operating system that's already on the machine, and within that operating system, you're going to install your virtual machines. So that's why we show the host operating system as being there. That's the original one. That would be like Windows or Linux or something like that. That's there. And then you install your hypervisor over top of that. It's not going on the bare metal. And then you have your host machines in there. And we've got, I think, a few diagrams like that. So there's a lot of customization that you can do. There's a lot of flexibility in the way that the hypervisor will work. This is really the benefit that you get from this virtual machines using hypervisor, is that you're going to get flexibility out of your machine. Your one machine can be doing lots of different things, can represent lots of different hosts, and you can allocate the memory and the other resources, which are virtual resources, through the different machines that are the virtual machines on it, according to the demand that they have. So you can make it quite flexible and useful. And so this is just showing you options in the configuration. When you're configuring your hypervisor, you see that you have these ability, as I just mentioned, that you can allocate to the different virtual machines. Well, yeah, okay, so this virtual machine, I'm going to give it this much memory. Now, obviously, you can assign a certain amount of memory to each of the virtual machines. The total memory that you assign must be less than or equal to the total memory on the physical host that you have. So you could put 3 or 4 virtual machines on there, and each of them sort of a gig of RAM or whatever. But then you'd have to have 4 gig of RAM on the host. So every virtual machine has its own virtual network interface card, and so it's going to appear as a machine on the network with its own IP address. So let's have a look at that. So it can connect to the other virtual machines within that little network that you have. So you can have a little network that's all just on one host, or you can sort of go through your virtual network interface card to the physical network interface card, and then out to the rest of the outside network. As it says there, it operates at data link layer, so not physical. So your virtual network interface card is not a physical card. It's working on at the protocol layer, at the data link layer, level 2. So you're going to have some limits imposed there by the hypervisor. It's not unlimited, and of course that depends on the resources that are available on the host computer. So we've got a couple of different ways of doing this. When we're talking about this, we're talking about maybe we can have a connection called a bridge. We got a couple of different ways of doing this, how we set up our virtual machines and our virtual network interface cards. And I think that's what the next couple of slides are about. So let's see. So here we have a single host and connecting with the virtual switch. The virtual switch means that inside the one box machine, it's as if we had a switch inside the machine. There isn't a switch there, but it's as if we have. And so that switch is then connecting to all the virtual machines that are hosted on that host. And each of them has their own virtual network interface card. There's no, I mean, as we see here, this particular host machine has its own two network interface cards, but there's 4 virtual machines on there, and they're all connected to this virtual switch, which is not a real switch. It's just set up by the software and with their own virtual network interface cards. Now, what are we trying to say on this one? The virtual switches exchange traffic through a router. Yes, okay. So between the 2 different interface cards, so what's happening in this one, I think it's 2 different hosts. Yeah, okay. So 2 different computers. And so these virtual machines connecting with those virtual machines will have to go through a router. That makes sense, right? Because they're like two different little networks, even though it's just two computers. They're actually two different networks separately, and so they're communicating that way. Well, maybe I should bring those down before I start. Various configurations. Oh, okay, now we get to the fun stuff. So we're going to talk about this bridged, NAT, and host-only ways of doing this virtual machines, virtual networks. So let's go and talk about those. So the first one is bridged. Let me bring the stuff down before I talk about it. So with the bridged, what you've got, if you look at the way the physical network is outside the host, what's happening out there is you've got your DHCP server is outside the host. So each of these virtual machines inside the host is going to be able to communicate to devices outside of the host using their own individual IP addresses, which will be, I guess you could say, discoverable by machines outside of the host. And they will use the DHCP server to get those IP addresses. And this is the way you set it up. So this is just you can set up, and you can see that they've clicked the radio button there to say that we're doing a bridged virtual machine network, right? As opposed to, we've got those other choices there. We could choose NAT or host only. Better if I wear my glasses when we're talking about that. So the NAT mode, that's another way. So I think you know about NAT. So what we're doing with NAT is the host is going to provide its own sort of IP address that's going to be shown to the outside network, and devices outside of the host will not be able to discover the IP addresses of the virtual machines that are inside the host. So in that case, we see the location of the DHCP server is actually inside the host. Remember in the previous one, in the bridge, the DHCP server was outside here, and that meant that machines outside could discover the IP address of these machines in here. Well, this one is not like that. DHCP server is inside the host, and so these IP addresses are not discoverable outside. I mean, that's only for inside this. This is like its own little network. You see, that's why it's got a switch in there. It's like its own little network, and that's how that works. And so what do we got there? Enable network adapter. Yeah, okay. So the host only is sort of similar to that. And again, it has the virtual switch inside the host. And so again, that's not going to be discoverable outside. Can't communicate with nodes beyond the host. So basically, it's just something living inside the machine or on the machine as a virtual machine, and is not discoverable or usable outside of the host. All right, so is virtualization a good idea? We do it. So maybe it's a good idea. It's going to give you some flexibility. It's going to give you some efficiency. So efficient use of resources. You've got a lot of memory on your computer. You've got a lot of other resources on your computer, and you can sort of allocate them to multiple uses, to multiple machines instead of just one. And so because this is all happening on one computer, that maybe is going to save you on electricity and energy, as it says. All of the errors that you might have, they're going to be on one machine for 4 different users or 3 different users, or however many you've done with that virtual machine. So there's your isolation of faults. Yeah, again, simple backup and recovery. It's all on one big hard drive, even though it's 3 or 4 machines. But that brings some disadvantages, and the disadvantages kind of relate to the same things that the advantages relate to, I suppose. You are going to slow things down. It's you got one CPU that's working as if it was 4 different machines, right? So that's a performance drag there. There's the one machine has more complexity to it, because for that one machine you got multiple NIC addresses, right? You got multiple operating systems even. I mean, because you could use with the virtual machine each one with a different operating system. You've got some increased complexity because you're using multiple versions of software. You may have more costs, and you've got a single point of failure. So the single point of failure problem is if that hard drive goes down or even the power connection goes down, instead of losing one computer, you've lost 4 virtual machines, right? So that's your single point of failure problem. So this slide is the beginning of, as it says there, 3 on a new topic. So that one, we were just talking about virtual machines there for a minute. And we're going to talk about cloud computing. All of these things are related, but slightly different. And I'm sure that you'll be familiar with that. So the idea of cloud computing is we're going to use a resource which is outside of our physical location in the cloud, as we say. So connecting through the internet, we're going to find providers that are going to give us services. So we use the term services that we can use in our business without us having to sort of develop them on site where we are here. We can take advantage of for example, Amazon Web Services. We can take advantage of their big server farms and use their capacity on a rental basis, paying by the month, instead of going and sort of building our own server farm. So there's some advantages to that as it gives us a flexible provision. It's an on-demand service. So what I mean by that is you sign up and you have a monthly contract, right? And so you could have a contract which only lasts a month. You're just trying something out, right? You're floating a business balloon, as they say, right? You're going to try out a system and see if that works. If it doesn't work, well, you shut it down. You pay 1 month and you leave it. You didn't have to go and build out a whole big sort of data center to do this. Amazon Web Services is going to do that for you. Multiple platforms. So what we mean by that is you could be doing some stuff with different operating systems. You could have some Linux stuff, you could have some Windows stuff, etc. That could all be provided for you through the cloud. But you could also have other development platforms that you could be using. Resource pooling and consolidation. So the resources there are going to be the resources of your service provider. It's a metered service. What that means is you'll be charged for what you use, not what you didn't use. So you can have a contract that would be like that. How much use are you using of their servers? If you're not using hardly any, then you'll be paying a lot less. The elastic services are kind of related to that. If for whatever reason your business grows really quickly, that can all be taken care of, right? They got the capacity. Of course, you'll pay more for it, but it can just happen, as again, without you having to sort of go and buy a whole lot of stuff. And on the other hand, if things collapse a bit, okay, what you pay goes down a lot too. So that's what we mean by the elastic. We can get bigger or smaller, and it's automatically scaled up and down for you. And that's all handled by these people in the cloud. Sounds wonderful, doesn't it? There couldn't be any downsides, could there? Well, probably. I'm sure you could think of some. So you can provide virtual desktops in that environment. Virtual desktop, a nice thing, I guess, about a virtual desktop is then you can have a thin client as your virtual desktop. Yeah, so you don't have to run a very powerful machine for that. You can have a lot of processing going on the service in the cloud. And so, as it says, their operating systems, you don't have to have it on your device, right? You can just send data to and from their service, and they have the operating system sort of hosted there. And as it says there, developers can load any type of software on there and they can test it. You could be working in a Linux environment today, and tomorrow you can try something on Windows. You can do them both. Give you multiple platforms. So this diagram is trying to show that. So here we are out here on the left. We're these users that are accessing the cloud, and through the cloud, we're getting all of these different services. Each of these, which is in a nice little orange box on the right there, represent the services that we could be getting. And those are all provided to us by the service provider in the cloud on a sort of a contractual basis. Yeah. So all we need is these very, very thin, small devices on the end there, right? And some kind of a connection to the internet, and away we go. And then, of course, pay for the service. Okay, so we've got, I'm sure you've heard of these before. If we want to separate them out into what kind of services are provided, I mentioned we use services. That's why we have all of these what do you call those acronyms that are end with a big S, because they're the different types of services that are provided. Well, at the top there, it talks about the traditional service. The traditional service, what we did before there was cloud services, is we built up our own systems. You know, we won't go and build a big data center. We put a whole lot of computers in there. We throw some people in there that can do the work. And, you know, it costs $1 gazillion. And, you know, maybe our business works or maybe it doesn't. And then if it doesn't, we got this big building full of computers, and what do we do with it, right? So that's the traditional. It's kind of, there's some, that's not all of that is bad. Not all of that is bad. And I'm sure you can think of that from the point of view of security. All of our stuff was in one room and we were controlling it. So, you know, that wasn't all bad. There was something good about that. And so we don't say that this doesn't happen anymore. You know, in some situations, that's what you're going to do. You're not going to outsource it to Blinken, Amazon Web Services. You know, maybe you're a security company or something like that that has a very stable sort of business, and maybe in a particular in one location. Well, yeah. Why do you want to use them? You know what you're doing. You actually need these machines. You don't trust them as much as you trust the guys that work with you. You know what I'm saying? Because you don't know them. All right, so you got a contract with them. You should be able to trust them. But yeah, I hope you know what I'm saying. All right, so that's the traditional way. We buy all our hardware, we buy all our software, we buy buildings, we put the stuff in there, and we run it ourselves, and we take all the responsibility. That's traditional. So we've got these other 3 different levels we can refer to. Infrastructure as a service. So what they're going to do with infrastructure as a service is we're just going to rent some, well, as it says, infrastructure. We're going to write hard disk space, if you like, storage space. We're going to rent memory space. We're going to rent all of the things that we would normally have to build up as hardware. We're going to rent that from our service provider, and we're going to take care of everything else. We're going to take care of the operating system. We're going to take care of all of the software that we're going to put on there. We're going to put that software on there. It's our software. It's our data, but they've provided us with the platform. I don't want to use the word platform because that comes with the next one, right? They've provided us with the hardware to do that. So platform as a service is kind of like the next step up from that. They're going to provide us with an operating system, maybe a development environment, and we're going to sort of go and just use that development environment and sort of build our systems in it. So we'll take responsibility for that software that we develop, but they're going to support the operating system, the development tools, and so they'll provide us with a platform as service. And the last one at the bottom is the one that sort of as non-corporate entities, as individual users who come across a cloud service. The cloud service that we're probably going to come across, you know, something like Dropbox or something like that, will be a software as a service. So basically, we don't have hardly anything to do with it, right? They might install an app on us, so we got like a thin client running on our phone or our computer or something like that. But basically, they're just handling everything on their thing. So they have the software, they manage it, they worry about the security, they worry about everything. They do all the updates. The only thing that we do is sort of sign up and take advantage of it. So that would be our software as a service. So this diagram is meant to represent that. The different colors there from white to blue represent the amount of responsibility for that that is shared between the actual owner of the system and the cloud provider. So when you had the traditional system, everything's white there. The owners of that system, they were responsible for everything. Well, of course, because they didn't actually have a cloud service. But when we go for infrastructure as a service, we do give quite a lot of responsibility to our service provider, right? Sorry, I shouldn't use that word because you'll be thinking of an ISP, to our cloud provider. So they're going to take care of the operating system, servers, storage, networking, virtualization. They're going to do that. We're going to be responsible for our applications and data support. Now that looks very similar to the platform as a service. Yeah, it does. But bearing in mind that the platform as a service is going to be maybe a development environment. you know, like a lamp stack or a lamp, something like that. So how we're going to do that development, they'll provide it with this. But look at the last one that I just mentioned before, our software as a service. They're taking responsibility for everything, basically. So they actually have, it's not our application. We're just renting their application for. Now I do that. I have a service of Dropbox. I don't know if any of you guys do that. And so I pay so much a month, right? I don't know where it is. I don't really care. I just have a login, and I have a app that I download onto my phone, and one that I download onto my other devices. And that's great, you know. I don't know how they do it. I don't really care. Don't know where the things are. I just know that I just have to log in, and there's all my files. They're there forever, and that's all very wonderful. So this diagram, and we've got another one which is sort of goes upside down from that. In a minute, we'll look at it. So in terms of what is it? Customers must understand more about the cloud provider's hardware and infrastructure than SaaS customers, ISS. So I guess you could say this pyramid represents our understanding that's required for us as users. So if we're using infrastructure as a service, we have to have a lot more understanding of what's going on. If we're only using software as a service, we don't really need much understanding. In other words, that represents that shift in responsibility, right? As we go up that pyramid, there's more of a shift of responsibility to the service provider. Now, I should have mentioned this. Well, I will mention it here. So we've got this other concept, which wasn't mentioned in those three. So we had the three, right? Infrastructure as a service, platform as a service, software as a service, anything as a service. Okay, so there's a broader model. The idea being that, you know, anything that you can think of, Internet of Things type stuff. I guess you could be thinking that way, right? So we might want to build some kind of application which is built around the concept of our Internet of Things. We're applying IP addresses to all kinds of things using RFIDs, et cetera. And we're building applications around those. Well, we would have some kind of cloud application that would pull that all together. So the upside down version of that is who's using it. And I guess you can see that, right? The software as a service, a lot more people using it. It's much more broadly deployed, I guess you could say. Software as a service. Application developers, they would be using both of those things, I suppose you would say, but there's certainly less of them than there are of end users, and network architects, less again. Okay, so the next one, let's not sort of get confused about this. I think what we've been talking about mostly so far in the last couple minutes talking about our cloud services would be talking about this first idea here of those services are provided in the public cloud. So the idea is, could they be provided in any other model? Well, could we establish a private cloud like an intranet, okay, and then provide those kind of services? Well, again, the answer is yes, we could do that. You could have a corporation which was large enough that we've got our own private sort of network, and then we provide services to users within that sort of network. So that would be that. So it's only going to be, you know, you have services and you could offer them. It would be the same kind of technology that these guys are using, but it would just be for private use within that company. It would have to be a big company. It'd be the kind of thing that a large, a government would do, or a very large company. A community cloud, I hope you can understand how that would be, you know, so basically a cloud which is sort of like an open source type of thing that that many people can sort of come and join and leave and that type of thing, or shared between different organizations, as it says. A hybrid cloud, so you could have something which would have different characteristics of many of these. Maybe you've got part of your network where you're providing services, which is private, and then you're also allowing some services through the public cloud. All right, so I did mention this at the start. Okay, why would we bother why would anybody use a traditional network, a traditional model, when we've got these lovely services? Okay, and so that's what you're meant to think about at this point, I suppose, is, well, maybe those services, there may be some risks associated with them, and these are some of the things that could happen. Well, what if your ISP, which is your connection between you and your service provider here, of your cloud service provider, what if your ISP has some issues? Maybe the ISP goes down, then you don't have access to your software. Maybe your ISP is putting bandwidth restrictions on you. And so, you know, that, especially if it's going to, I suppose that could happen. Some ISPs, like here in Qatar, our ISP is a Rito. We only have one, so they can basically, they really control you a lot. I mean, so I suppose if they, for whatever reason, they could say, okay, we're going to impose a bandwidth restriction on you, or there could be some problem with their own sort of connections. You know, somebody trolls out in the Gulf and pulls up the cable. That's really kind of independent of that, but yeah. So the cloud provider themselves, so the guys with their server farm in Iceland, you know, the Amazon people or whatever, they may have some issues with their hardware. You know, maybe they might throw some risk into it. You know, what I mean is, you build your own system. I suppose you could have a system where you had your own power sources and things like that, and you know, your own building with all of the machines in it. It could be pretty independent of these risks, you know, as opposed to sort of relying on a connection to Iceland. And you know, maybe Iceland has a volcano. That does happen in Iceland. They do have servers in Iceland. Maybe Iceland has a volcano go off and then their servers go down for a couple of days. I don't know if that's ever happened, but you know, maybe it would. You know, that Iceland is a sort of favored place for that type of server farm, and so is Ireland. And because it's cold, so Iceland, you can just sort of, you can have your server thing, you just open the windows. And well, of course you're going to use some air conditioning, but you open the windows, it's already cold, right? You know, with a server farm, you got to keep it cold. I mean, this would not be a great place for a server farm. You know, it's 50, computers don't operate at 50 degrees very well. So yeah, that's a big benefit they have in Iceland. There's a system that they have in Netherlands, which is sort of a kind of like that. How that works is that the cloud provider will provide you with a free, it's like they put this device in your house and it produces a lot of heat. So it's like a free heater, but it's actually one of their network components. And so they will come and install it in your house, keeps your house warm. You get free warmth and they get free cooling, right? It's because your house is cooling down, is working as a sort of a heat exchange. And then you've got sort of a free sort of connection because that device is connected to their network. So yeah, you could have some configuration problems that are outside of your control. I mean, that's the problem, right? You are relying on the expertise of these cloud providers. Now they should be good at it, right? Because that's all they do. So yeah, you expect them to be good at it, just like the same way that you take your car to a mechanic because that's all they do. You expect that they'd be better at it than you would. Now the breaches of confidentiality, I mean, I mean, it's up to you what you put on there, but you're using a cloud service. Your data is located physically, you know, on this server in Iceland. You know, okay, so you've got all kinds of encryption going on, you know, but it's still there. I mean, if somebody wants it bad enough, it might be easier for them to get it while it's in Iceland and they're in Iceland than it would be if it was in your hardened facility, you know, underground where nobody knew about it, you know, which you could do if you had your own traditional thing, right? And so data security regulations, maybe there's some laws that are international that don't sort of suit you, those kind of things. Ownership of intellectual property. So whenever you have a contract with another person to provide you with something, or then you open the door to these kind of disputes. You know, you don't pay them the money, so they grab all your data. You know what I mean? I don't know if that's ever happened, but I suppose it might. And then the data maintenance, right? So, is your database being kept in a uncorrupted form? So what if something happens, are they backing it up? How often are they backing it up? Where are the backups? Who owns the back? I mean, these kind of things, could bring you some heartburn, I suppose. And yeah, the propriety data. Again, those are basically just, I think we've sort of covered all of those. So how can we reduce the risk? Encryption is pretty obvious. We're going to encrypt everything that goes between us and out in the cloud so that hopefully they don't sort of get access to us. There are ways of breaking encryption if you want it bad enough, but it needs a pretty motivated sort of hacker to do that. And okay, so again, you'll be looking at how secure are your access. How are you sort of going about that? And I think that's where we get in the next couple of slides. So I think we got 4 or 5 slides where we talk about how we can, what kind of security protocols do we use when we're connecting between things over long distances, et cetera, and through the internet, et cetera. Okay, so there's all different ways that we could connect to the cloud service. Yes. Oh. How many more slides have I got? So yeah, we do have, before we talk about those protocols, we do have this VPN sort of topic that we do need to talk about. I'm sure you've heard of a VPN, virtual private networks. We use virtual private networks here. Encryption is a big part of virtual private networks. So what we end up with is, as I said, of a encrypted data going from a point to a point. Encryption is really the key. So we sometimes refer to that as a tunnel from one point to another so that you can connect between 2 different points. And it's as if you had a tunnel. Actually, your data is going out in an open network, but other people are not able to sort of use it because it's encrypted. And so that's why it seems like it's a point-to-point thing. So we have various ways of doing it. We can do site-to-site VPN, which is going to go from your like your router to your router, your server to your server, client to site. Hope that's obvious. It's also called host to site, as it says, remote access VPN. So here at the college, we can log in, we can sit at home and we can log in and use a PeopleSoft in the previous version of the PeopleSoft through a VPN access. And so I could pull up my desk, how my desk would look if I was sitting at my desk here at work on my laptop at home by connecting through a VPN. So that was good, very nice during the COVID lockdowns. And that would be a client to site VPN. All right, so here we have a virtual private network, which is connecting various large sort of facilities in spread out geographically. So each of those lines between them represents what I guess we use a word tunnel for those, but they're not sort of physical, are they? All it is we connect to the internet and we put some extra encryption on all of the messages that we send. That's how the VPN works. And then that communication arrives at a different location and they're able to use it. So that encryption is happening using these boxes. We got these VPN gateways that make that are the ends of those communication. So that's one implementation of it. You can see there. And the other one that we've got here is we see these clients out here in a remote location, and they want to have access to their business software, which is in this location here. And so they're going to have this client to host sort of virtual private network that they're allowed to connect in through. And that would be like the one that I mentioned that we have here at the college. Yeah, so we've got 2 different ways of doing it, I suppose we're saying here. We could have a router-based VPN. And if we're using Unix-based networks, that would be the more common. as opposed to, or opposite of, I suppose you'd say, would be server-based VPNs, and that's how it's implemented in network, Windows networks. We have this concept of a VPN concentrator. So a VPN concentrator is going to be like a separate physical device, which is going to sort of provide the network connections for all the different devices out there that are part of your VPN. So it established, in the words of the slides here, it establishes the tunnels for the VPN connections. So it kind of looks in your network, it kind of looks like a router type device, and it does the encryption that makes that VPN transmission possible. All right, so how do we do the encryption? We got a couple of different protocols that make this possible. I don't know if you've heard of these protocols before. Ipsec is a protocol that runs at the network level of the OSI. All right, so that's level 3. So that's the IP level. And the other one we've got is secure socket layer, which is working at the transport layer. So level 4. So level 3 and level 4 security. So they're both security, but they're just security at different level in the OSI model. And as we've talked about before in security a little bit, is what we want to have is we want to have multiple layers of security, right? And so we can provide security at many levels. So there's the concentrator that I was talking about in a previous slide. So it's a device that's going to provide these virtual connections that make it possible for these devices out here, sitting on this switch in our little network here, to communicate with these devices out here as if they had a sort of a one-to-one connection to them. And likewise, these devices are going to be able to communicate to these. Maybe this is a server here, and so our user out here on the internet is going to be able to have a tunnel that goes through to that server, and that's all going to be by authentication and encryption. That's going to be added to the packets that are sent through. The thing that's meant to show you here is, well, let's get the notes up about it. We have a dynamic multi-point VPN. So what we see is we would call this a hub and spoke sort of idea. And so the idea there is we can dynamically develop the links between the different routers as required. And so as it says there, Cisco makes that possible. Cisco has a protocol for that. So it dynamically creates the tunnels. I guess each of these lines here would represent the tunnels that are being created there as required. So as required by the demand for the traffic. So you don't need to have a constant static tunnel there. The tunnel will be developed there as it is required and only then. Okay, so the next stuff here in this slide is just sort of general, apple pie stuff. What should we do so that our network connections to the cloud, etc., are secure? And so that's basically all that is. I'm sure that you've heard all of this stuff before. All right, so when patches come through, we would install them, because patches are going to typically they're going to make a fix to a exploit. So an exploit was created, and we are going to patch for it. Passwords, biometrics, two-factor authentication, that type of thing. So there's some stuff about passwords. I'm not going to give you a lecture about passwords just because that's there, because we also did talk about that before. Encrypting our storage devices, that's a good idea, so that people who may have physical access to them don't sort of steal our data. Secure the areas where, so we have locks on doors, that kind of thing, right? So just basically different layers of security. I think actually the last one, no, never mind. All right, so there's some more here. We might have people that are accessing a VPN to access our servers from remote locations, right? So maybe they're doing work, like I said, I can sit at my house and I can go onto PeopleSoft and change people's grades and stuff like that. I can do that at home. I don't need to come into work and do that. So, you know, if I was working in a fairly sensitive business, maybe I could have that kind of facility. I might be able to even sit there with my phone and do that. So there's some security risk in that, right? I mean, so supposing I'm on a Wi-Fi, you know, sitting at the airport, maybe, you know, and I'm accessing some very sort of sensitive work stuff. And, you know, so what else is going on my phone, right? You know, do I have another browser open somewhere else? You know, is it possible that somebody is going to, by some means, get access to what I'm doing in this browser over here? And so those are the types of things that we might want to have. So we might want to force those things to not happen, so that if we're using the VPN to sort of get into our secure access there, that we close down all other sort of browsers and other connections that we're using. Yeah, so if we're remotely connected, we're not connected to the open internet, that type of thing. All right, so the next 4 slides are supposed to be a summary. But what I noticed when I looked at the summary there is there's actually a lot of points that aren't discussed in the previous slides. So it is worth your while sort of just going through and looking at the summary to make sure you sort of understand everything that's going on there. But I think we get the idea of what virtualization is. Virtualization is logical, it's not physical, but it will be something which is hosted on a physical device. Virtual machines can go through a virtual switch. We got 3 different ways of doing virtual machines. Go back and look at the slides earlier, and you'll see those 3 different ways. So that is a review of what was talked about. So we got the bridged virtual machines, virtual networks. So I hope if you remember the bridge, what's happening is each of those devices on the host actually has its own IP address, which is discoverable outside because it's getting its IP from the DHCP server, which is outside of the host. And network functions virtualization. We didn't talk about that. So as I said, we've got some new things. Network functions provides flexible cost-saving options, many types of network devices. I don't believe that was mentioned in the previous slide, so that's probably worth sort of paying some attention to. Software-defined network is a defined centralized approach for networking that removes most decision-making power from network devices. So basically, that's sort of related to your virtual machines, because you're doing your virtual networking. We're doing this through a software function. Cloud computing. We just finished talking about that. That is a review. There's various different models. The different deployment models, remember, we could do it all in the public cloud. We could have our own private cloud, or we could do some sort of mix of those things. Hosting websites, server farms, we talked about that. Encryption is the big deal in doing our cloud computing. We need to make sure that everything that goes out and comes between is encrypted, and it's encrypted on them. I think the next couple of slides does talk about that, right? Yeah, so IPsec, Internet Protocol Security, which is working at your level 3 of the OSI model. So that is going to apply encryption and authentication. So you can set that up and use that. Secure socket layer and TLS. Okay, so they're different. They're working at the transport layer. Both of those work at the transport layer. And so that they also provide a different and at a different layer form of security. Point-to-point protocol. That's in an earlier slide here, I showed you the diagram, showed those 4 different cities. Remember that? There's Boston, you know, New York, whatever. And they had the VPN that was being used between them. Okay, so that would typically be your point-to-point protocol. Your point-to-point protocol is going to be between your routers on different networks, sort of providing that WAN type access. terminal emulation. So we can connect to another computer, and then we can take over that computer using a terminal emulation. So for example, the IT department here, they do that. They will install for you software remotely. You know, you have to give them permission to do that. They do let you have that much control, but they will take care of it. You'll see that I've had them do that for me a couple of times. Can you please install some software? I say, okay, they ring me up and they say, okay, give us your permission to do this. And then I take my hand off and I see the cursor going all over the screen and stuff like that. They're doing this kind of terminal emulation and taking over my machine. So here we have the a bunch of protocols that sort of make the encryption and the connections possible for this type of remote computing, I guess you could say. A secure shell, it's as it says, a collection of protocols that make it possible. RDP, that's going to allow you to do the remote desktop, which I was just sort of referring to then. There's a bunch of file transport protocols. Now, they all kind of do the same thing, except the TFTP, that's a trivial file transport protocol. It's only used on sort of private networks. So we don't use that out in the cloud or anything like that. The other ones do. This is just our basic file transport protocol, and then we've got two secure ones. So you got file transport protocol secure, and then secure file transport protocol. You might say, oh, well, they're the same. Well, they're not actually. One of them uses the Ipsec, and one of them uses the two transport layer protocols. So the transport layer protocols, I believe they say, are more secure. And that's it. So we did make it through. I'm sorry, I did talk a lot on that and I went quickly, but I was recording. And so I will put this